Hello, geography. My name is Mr. Wester, and today we're going to be looking at population and more specifically where people live. That's going to be kind of known as density. We're going to go through the different types of density in regards to population that geographers look at, study, in order to kind of tell where people live and why they live there. Now, why is it important to study this? For geographers and city planners, people in the government, they use this kind of information to know whether or not they need to, for example, build more schools in an area. If a lot of people are moving to that area, if the population is growing, they might need to build more stores, build more schools, build more houses. If people are leaving that area or there's not as many people living there, they'll have to adjust to that as well. So it's kind of important for people who are planning on the future to study this information. It's also going to talk about why people live in certain areas of the world and maybe some other areas they stay away from. If you look at this map, you can see that 2/3 of the world inhabitants are clustered in four different regions. So 2/3 of the world's population are in these four regions. It's East Asia, South Asia, Southeast Asia, and Europe. So you can see this type of map. It shows on population. So you can kind of see it kind of resembles a normal map if you're looking at it, but the countries are different sizes. That's because on this map, it shows up by population. So for example, if you look up here, this is not Russia like you would think it would be. This is China because China has one of the world's largest populations in it. It's going to represent bigger on the map. Same with India. However, if you look over here and you see Canada, Canada is almost, you can barely see it because they have such a small population compared to the area in which they live. So the larger the country on here, the higher the population is. So 2/3 of the world's population lives here in Asia and in Europe. So now we're going to kind of discuss why that might be. Some regions might be too hot, some might be too cold, some might be dry, some might be mountainous, so it's harder to live there. For example, if you look down at the very bottom of the map, you don't see Antarctica at all because nobody lives there besides some scientists. Because it's too cold, you can't sustain life on there. Same with if you look in northern Africa. It's a lot smaller because there's the Sahara Desert there, so it's very hard to kind of live there and grow a population to be larger. But you see places like China and India and Europe where the countries kind of are more suitable for people to live. The weather's better, the land is more fertile, and more people are growing and populating those areas. This type of map is called a cartogram. It depicts the size of the countries according to the population rather than the land area. So like I said in the previous slides, this shows the size of the nation based on population, not by the size. People who are making these maps try to stick with the general shape of the nation, but they either make it bigger or smaller depending on the nation's population. So the world population of last week was 7.8 billion people. So there's around 7.8 billion people on this earth right now, and it's constantly going up. So this is a cartogram map. There's three types of density we're going to look at in regards to population. The first one is arithmetic. This is going to be, you might have heard the term population density. That is what arithmetic density means. We'll go over these more specific. The next is physiological density. A lot of times we call that farming or available farmland. And then we have agriculture density. So the amount of farmers per farmable land in the nation. And again, we'll go over these in a little bit more specific on the next coming slides. The first one we're going to look at is arithmetic density. Again, we kind of call this population density. So if you hear the two terms, we use them interchangeably. Arithmetic density is the total number of people divided by the total land area. So this one's kind of the most common. You think about when you talk about population, how many people are living in a certain area. Where we see most people live, we call these population clusters. It's the units in a population partitioned into a large number of groups So if you look at the map below, you can see the population clusters. The more people are living there, the darker red it shows up on the map. And you can kind of see where people are living. Uh, for example, if you look at India over here, you can see it's very densely populated in here. Same with China. However, if you look at Northern Africa, the Sahara Desert is very what we call sparsely populated. It's an area that contains few people. Same with the United States and Canada. You see the East Coast, even the West Coast, you can see some color. But in that middle of America and in Canada, where there's less people living there, you're going to have less dots. So on this type of map, you're going to see the more people where they live, the redder, the more tightly knit the dots are going to be. And again, that kind of goes to what's there and why are these people living there or why aren't they living there. Goes to Northern Africa, the Sahara Desert is too hot, too dry to really grow things. So you're not going to see many people living in those areas. Same with Northern Canada. It's too cold. There's not very much farmable land to kind of grow, sustain life there. So you're going to see less people. And that is what arithmetic density is. It's just calculating the number of people divided by the total land area. You can do this for nations, for cities, things like that. The second one we're going to get into is called physiological density. It measures the people who are supported by a unit area of arable land. And arable land, we can kind of call that farmland. Arable land is land suited for agriculture. So land that is capable of growing things in it. It's really important to kind of see on maps when you're looking at population and how much arable land or farmable land is there. Can a nation with their growing population sustain itself on the agriculture that they are providing or they are farming? It's going to be important to kind of look at these numbers. It shows us the relationship between the number of people and the availability of resources to them. So if you're a nation that doesn't have a lot of farmable land, but you have a high population, that means you're going to have to go find your food elsewhere. You're going to have to import products from other nations, and you're going to be relying more on others rather than producing it yourself. The next kind of density kind of correlates with physiological. It's called agricultural density. This is the ratio of the number of farmers to the amount of arable land. So physiological density, we looked at just the amount of farmable land per population. Now we're going to be looking at the number of farmers to the amount of farmable land. So how many farmers does it take to farm that land? If you think to yourself, do you know any farmers? Maybe you do. For example, I grew up in Iowa. My uncle's a farmer. My grandpa and grandma were both raised on farms. A lot of my friends are farmers. However, you guys might not know any farmers. Living in a city like Coon Rapids, you might know a couple, but the odds are you don't know that many. It's because the United States doesn't need as many as other nations. So if you look at Canada, United States, we have a very low agricultural density. And that's for a couple reasons. I want you guys to pause and think right now, why do you think some nations like Canada and the United States would have such a low agricultural density? But if you look at countries like Egypt, you have a very high agricultural density. So what kind of factors would kind of come into play in regards to how many farmers you need to farm the arable land? There's a couple of reasons why. A lot of them come back to economic. Developed countries, like you see in the image above, have access to technology and finances to farm on a large scale. So you might have one farmer owning thousands of acres of land, and he can do that and farm that because he has tractors, he has combines, he has all these different tools to help grow his crop and allows him to farm a large area of land. While you look at other nations where you might not have the ability of the technology, you might not have the ability to finance a combine, be able to buy one because combines are very, very expensive. So you might have to do things by hand. This requires more people to farm, which creates less work in other professions because there needs to be so many more people on the farm. So in a lot of these developing countries, you can see their agricultural density is higher because they don't have the machines as we do in other developed countries. So they might have less arable land or farmable land, but they might need a lot more farmers to farm that just because of the styles of farming that kind of come with the nation that they're in. If you look at the map, you can kind of see where it's darker is the larger amount of the higher agricultural density. So more farmers are needed to farm smaller areas of land. So you can kind of see a correlation in things like, and maybe the more developed countries like United States, Canada, Brazil, Russia, in Europe, they don't need as many farmers because they're allowed to, they're able and capable of farming larger areas under one farmer, while you see countries who are still developing, who have a lot of people who don't necessarily have the technology and capabilities to farm on a large scale. So they're going to need more people, more hands-on, and you'll kind of see that correlation going forward with other developing nations. So that's agricultural density. So after you look at the different types of density, so remember we have arithmetic density, it's population density, so how many people are living in a certain area. Then you have physiological density, when we're talking about how much farmable land there is per area. Then you have agricultural density, with how many farmers are needed to farm that farmable land. Next, we're going to look at population pyramids. These are going to be tools you're going to be looking at kind of throughout the try, looking at different populations in regards to different places of the world or different nations or different people in the same nation. So you're going to be looking at population pyramids, so it's going to be important that you know how to read them. A population pyramid is a shape, usually when we're talking about population, it's the shape of a country's pyramid is determined primarily by the crude birth rate. So you're looking at population, it goes by age. So usually the youngest is on the bottom, and then it goes all the way up to the older the age. So how you kind of determine this, how you map this is based on the crude birth rate, so how many people are being born over time, and then it kind of goes on to how many people are still alive at a certain point in their life. So you can see it kind of has a shape going up because more people are being born. And then as you kind of go on, it's kind of sad to say this, but people die as you go on. So you're going to always be replaced. So there's a lot of younger generations replacing the older generation. So you can kind of see that. You can also use different population pyramids to look at different things and kind of determine how the rate of growth is going. So if you see Kenya, their younger population is a lot bigger than their older population. And we'll look at different reasons why that might be. But if you look at America, where we have a slower growth, it's not as drastic as it would be in Kenya. It's still a growth. You can see the line, but it's not as much. It's not as rapid as this one. And then you look at Italy, where there's really zero growth and kind of a decrease in population. So less people are being born than are dying. Less people are being born, and their kind of people are getting older and not dying as fast. So it's harder for them to get replaced. So their birth rate is lower. Here's another map, our population pyramid. It's a term you're going to hear us use a lot is life expectancy. Some of you may know it, but it's the average number of years a group is supposed to live in a country. So the life expectancy of a male in America might be different than the life expectancy of a woman in America. Women tend to live longer, so they might have different life expectancies. Typically, when you're looking at nations, you kind of just say one number. So say, this is totally random. The life expectancy in Japan is 84. That would mean on average, that's how long someone would live for. And you can look at the United States in specific. We talked about this in the last slide. but our growth is slowing down compared to like somewhere like Kenya, where there's a lot of people being born and not as many older people. But you can see in America, our middle kind of the economically active, so the people in the workforce, is a large portion of our population. So here's kind of a game to help you read population and kind of see how you can read maps, knowing on maybe what the town is made out of mostly, and looking and taking guesses on which population pyramid that town would relate to. So if you look at this map, it shows 6 or 8 different population pyramids. On the top right, you see the different cities that they relate to. So your goal is try to guess which city belongs to which graph. Now it's kind of important because maybe you guys don't know the cities as well. So here are some clues about this. So Ann Arbor, Michigan. Many of you maybe know that, maybe you don't. It's where the University of Michigan is. So what do you know about colleges or college towns? There's a higher rate of younger people from the age of 18 to 23. So maybe you look at the population pyramid, try to find where is there which population pyramid kind of shows an extreme population gap or growth from that 18 to 23-year-old mark. You could also look at things like Punta Gorda, Florida, which is a retirement community. So where would you think the most of the people, the average age of that town would be? If it's a retirement community, it's probably because they're older. So then the top of the graph, this older age, there'd be more people living there. So maybe you'd guess it'd be 5, because you see a lot of the population is older and less younger people. So what I want you to do is kind of try these out. I'll let you pause it here. So you can pause it, fill out some answers, see if you can get some of these right. When you're ready, just unpause and I'll go show you the results. So here are the answers to the problem. See if you got them right. See if you got them correct or not. That's going to conclude the talk about different densities in regards to population. Remember the 3 different types of density. We have arithmetic, which is like population density. Then you have physiological density, and then you have agriculture density. You should be completing those different learning targets on your learning target guide, and that's where we're going to leave it off for today.